Okay, so to get us started on parallelograms, we first have to review a little bit. Does anyone remember what these symbols mean? It means that they're parallel. So I want to start by going over some things about parallel lines that we remember. So can anyone tell me one thing you remember about parallel lines? They never touch. That's the definition of parallel. They also have the same slope by definition, so that way they never meet. What else do you remember about parallel lines besides the fact that they're parallel? Like, what about the types of angles that we have?
They make like alternate interior and exterior.
Okay, so let's start with alternate interior. In this picture, what is an example of alternate interior angles?
Oh.
Krista?
I forgot. Wait, 6 and like 3 or 5.
6 and 3. So angle 6 is congruent to angle 3 because alternate interior angles are congruent. And 4 and 5 would be our other pair. Alright. We also, I heard Tyler say, have alternate exterior. So who can tell me what a pair of alternate exterior angles are, Caitlin? 2 and 7. And what's the other pair? Let's go with J. 1 and 8. I know. Okay, so those are two types. Can anyone remember another type of angles that we have with parallel lines? Peyton? We have corresponding. So let's see, who can give me an example of corresponding angles?
2 and 6. Angle 2 and angle 6.
Angle 2 and 6.
1 and 5.
And then I heard 1 and 5. Not quite 1 and 7.
Yeah, it's gonna be 3 and 7.
3 would go with 7.
And 4.
And then angle 4 and 8. Okay, so corresponding angles are also congruent. Okay, there's another type. Anyone remember the other one? Same side interior, also known as consecutive.
Is that like 3 and 5?
That's 3 and 5. 3 and 5 are considered consecutive. What do you remember that's different about consecutive? Because they're not congruent.
Oh,
Oh,
they add up to 90? I don't know.
don't they add up to 180?
They add up to 180. And what's the other pair of consecutive interior?
Wait, listen, could you
4
say
and
like
6. 4 and 6.
4 and 6.
could you say 3 and 6 or
No, 3 and 6 are alternate interior. Those are congruent. Same side, so 3 and 6, see how they're on alternate sides of the line? We need to be on the same side.
no?
Okay, there is one more type of line here. Or angle, sorry.
Oh, linear.
We don't really do linear.
Is that the word?
Well, it is. I'm not saying it's not.
Supplementary?
What were you going to say, Peyton?
I said vertical.
Okay, I did hear someone say vertical. That was the other one I wanted to touch on, was vertical. I guess you could have, I don't know, consecutive and exterior. I don't know if that's really anything. Okay, but vertical angles, and what do we what's a pair of vertical angles in this picture?
1 and 4.
1 and 4. 7 and 6, 5 and 8, and 2 and 3. Okay, I'm not going to list them all. Okay, but vertical angles as well. So one of the things with parallelograms, what's the key word you hear in the parallelogram? Parallel, which means we're going to have these relationships in our figures. So that's why I wanted to kind of just go over them, because we're going to have these same angle relationships. Okay, so let's draw a parallelogram. Mr. Hall wants to see you after we're done with this. Okay, so a parallelogram. A parallelogram has 4 sides. Usually it looks something like this. Doesn't have to, but usually it does. And what makes it a parallelogram is that it has 2 pairs of parallel sides. Okay, that's what makes a parallelogram a parallelogram. So as long as opposite sides are parallel, you will have a parallelogram. Okay. Now, with parallelograms come 4 properties that once we know it's a parallelogram, we know can be true. So has anyone ever seen this shape before? Yeah. Okay. That's a good thing. Can anyone tell me one thing you remember about this shape?
It has 4 sides.
Besides the fact that it has 4 sides. Hmm?
How to find area is base times height.
Okay, the area is base times height. That's in Unit 9. We're not there yet.
Oh.
You're not wrong. We're just not there yet. Anything else you remember about this shape? Tyler?
All the angles add up to 360.
Okay, the angles will add up to 360 because it is a quadrilateral. Peyton, what were you going to say? You were going to say that? Okay. One thing that we know about parallelograms is that opposite sides are congruent. So I know that opposite sides will have the same measurements. That's our first property of parallelograms. Our second property of parallelograms, opposite angles are congruent. Our third property is consecutive angles are supplementary. So for example, if I were to put labels on this, A, B, C, D, I can say angle A plus angle B will equal 180, as well as angle B plus angle D will also equal 180. So any 2 angles next to each other, whether it be A to B, B and D, D and C, or C and A, whenever there are 2 angles that are not opposite and they're next to each other, they're going to add up to 180. Our fourth property has to do with the diagonals. So if I were to draw the diagonals, the diagonals bisect. So what does that word bisect mean? It means cross, but how? It cuts it into in half. So that means if they're going to bisect each other, then each half, so BC will be cut in half, and AD will be cut in half. These are four properties that will be true when you know it's a parallelogram. So we're going to go through 4 examples where we have to solve for x, but we also have to state which reason lets us solve for x. So in other words, which of these properties is helping us find out what x is. Okay, so if we look at our first one here, let's put it in our bag, not our pocket. You put it in your bag, not your pocket, so you don't hit it again. Okay, so how might we solve for x? Thinking about our properties over there on the right. So what kind of angle is x in 53? Set what?
X plus 53 equals 180.
It is x plus 53 equals. Okay, so which of these properties told you to do that? Which of the properties tells us? They're consecutive angles. They're angles that are right next to each other. Consecutive angles have to add up to 180. So we would say for our reason, consecutive angles are supplementary. So to solve it, we do x plus 53 equals 180. I told you you were right. So when you solve, you get x is equal to 127 degrees. Yes, Tyler.
I don't know if this is wrong, but could you say they're same side interior?
Consecutive and same side interior are the same thing.
Oh, yeah.
So yeah, you could say that. Just consecutive is the more mathematical term that gets used, so I'm trying to get you guys to say consecutive as opposed to same side, but they're the same thing. Yeah.
So you don't find the rest of the...
Nope, right now we're just finding x.
Okay.
Now, could we find the rest of them if we wanted to?
Yeah.
Yeah,
Equals
because
360, right?
it does, but what it's using another property. What do we know about opposite angles?
Alternate exterior.
Well, what do we know about opposite angles in a parallelogram? They're congruent. So if this is 53, then what's this? If this is 127, what's this? So we could if we wanted to, but we don't need to. Okay, so let's try another one. So again, we want to state what property do we use to help us solve for x? And then we're going to solve for x. So from these properties up here, which one do you think we can use to help us? Tyler.
Consecutive.
We have consecutive again. Okay, even though these are the bottom two, they're still consecutive because they're right next to each other. So we would say consecutive angles are supplementary. That would be our reason that we can use. So x plus 113 equals 180. So x would equal 67. Okay, how are we doing so far? Okay, the whole first page of your assignment is doing just this, where you're going to have a parallelogram, you're going to need to solve it, and then state what property you use to solve it. So we're going to do 2 more.
I think we should do 2 more on the packet.
How about we do 2 more that I have already done, and we'll get to the packet in a minute.
Or I can just do
What was that? So much over.
Or you can just do them on your own, that's fine too. Okay,
Tyler.
so here we have this angle and we have this angle. So we want to start by, after we draw it, looking at it to see which of those properties can we use to help us set up an equation that can solve for x. Well, do we have sides? Opposite angles are congruent, so that can be our reason. Opposite angles are congruent, so that means that 6x plus 10 has to equal 130. Move the 10 to the other side, divide both sides by 6, and we get that x is 20.
You plug it back in.
Nope, it didn't. The directions just say find x.
Okay.
I didn't write them out because I didn't think last time I wrote them out I ended up not having enough space. So I just verbally said that we're just solving for the variables. On your homework it will say in the directions whether or not to plug back in.
Alright.
Alright, so this last one for the front page, or that's like the front page of your assignment. Okay, so again we want to look at our properties and think which one helps us solve for x or y. And in this case we do have 2 letters to solve for. Not vertical. So we're looking at, look at the 4 properties of parallelograms. Do you see the 4th property about diagonals? The diagonals bisect each other. Diagonals connect. No, diagonals connect opposite corners. Okay. If I zoom in too much, it's gonna cut the. Yeah.
When the angles bisect, the sides are equal. Or the angles are equal. No, the sides are equal. So that would mean 6y plus 1 is equal to 4y plus 9.
Yep. Okay, so again, I'm just gonna write out our reason first. Diagonals bisect each other. That would be our reason, or our property. And then we would set 6y plus 1 equal to 4y plus 9. So 2y equals 8, y would equal 4. And then what's the other equation we can set up? 2x minus 5 will equal x plus 7. So we get x is equal to 12. Okay, so like I was saying, the whole front page of your assignment is doing just this. You're going to solve it, and then on the 3 lines where it says property, you're going to write one of the 4 properties of a parallelogram. So what you're writing for your properties is one of these 4. You just have to pick which one. Okay? Any questions about how to do the front page of your homework? I'm getting there. Okay, any questions about the front page? Oh, yeah. Okay, so what do they tell you in number 2? Huh? Well, they tell you what each side is. So like DG, you would write 2x plus 2 as that side length. And then for DE, 3x plus 1. And then EF, 3x minus 3. And then 2x plus 6 would go between G and F. So we're given all those side lengths. Well, which property talks about side lengths? Opposite sides are congruent. So that means once I have them written on my picture, I can set the ones across from each other equal to solve. Okay? Sorry, I'd put mine up there, but it's got all the work on it, and I don't want to give you guys the answers yet.
Can you show us 4 again? Like just on paper?
Yeah. Okay, the other half of what you're doing, so if you look at the back side of your paper, of your homework, we're going to go over how to tell if you have a parallelogram when it doesn't tell you. So like on the front, we're being told that those are all parallelograms, meaning we know all those properties are true. So the back side is saying, well, we don't know they're parallelograms, but we're going to go over how you can check that they are, in fact, parallelograms if it's not given. So, how do we prove to ourselves that we have a parallelogram? You just tell yourself? No, there's actually ways to convince yourself to prove parallelograms. Say that again?
The property?
By seeing if the properties are there. Okay, that's exactly how you prove it. And then there's one in addition to the 4 properties. So there's a total of 5. But the first way, show opposite sides are equal. And you have to show both pairs. So if you can show opposite sides are congruent, you have a parallelogram. Our second property was about angles. So if we can show opposite angles are congruent, again, both pairs, then you have a parallelogram. What was another property? Okay, show the diagonals bisect each other. I'll write that one next. Show diagonals bisect each other. And then show consecutive angles are supplementary. And again, you have to show 2 pairs. Okay, so those are just your properties. If you can show that one of your properties is true, you can say it's a parallelogram. Okay, there is a 5th one that you can also use. This 5th one says if you can show one pair of sides, both congruent and parallel, then you'll have a parallelogram. So when you're looking at something like 6 through 11, so when you're done writing these down, go ahead and open your packet to number 6 through 11. If we look at number 6, is that a parallelogram? And if so, which of these 5 tells you it's a parallelogram? The 3. Number 3 on our list. Show diagonals bisect each other. So because in number 6 our markings show that the diagonals are bisected, then yes, you can say it's a parallelogram. So that's exactly what you would write. Yes, because the diagonals bisect each other. So there's number 6 for you. If you were to go to something like number 9, look at the picture in number 9. Do any of these 5 properties fit number 9?
What?
Okay, so number 1, opposite sides are congruent. We have to show both pairs of sides. So in our picture for number 9, do we see both sides congruent? Both pairs? We see the top and the bottom, but do we...
Number 5. But what are those? I see number parallel. 5 means they're congruent.
Okay, but hold on one sec. So Krista, do you see why it's not opposite sides? Okay. So Chloe, you said you see the 5th one. One pair of sides, both congruent and parallel. Now it has to be the same pair that's parallel and congruent.
Oh, I thought it was 2 different.
No, so and that's why number 9's on there. Because number 9, it's making you think it's one pair of sides, both congruent and parallel, but is it the same pair that's both congruent and parallel? No, these were the congruent ones, these were the parallel.
Has to be on.
It has to be on both. So if it was these 2 were congruent and these 2 were parallel, then we'd have yes. This one's nothing. It's not, we don't have enough information. Number 9 is no, we don't know, because it has to, and our reason or our explanation would be something like it needs to be the same pair of sides that's both parallel and congruent.
So you gotta explain why.
Yep, you got to explain like what's missing that you need to know.
Oh, so it's not enough information and see,
It's not enough information. It's just.
It's the information's not in the correct spots for us to say it. Okay, so that's what you're doing on 6 through 11. So you have 4 more there that I want you to look for one of these 5. And if you don't see one of these 5, say what's missing or what else would you need to know so that you could. Okay, numbers 12 through 15. I want to do at least one example that that looks like 12 through 15. Because 12 through 15, it doesn't tell you have a parallelogram. It's asking you what values will make it a parallelogram. So when we look at something like this, where we have a shape, I'm gonna slip there, a shape that looks like it's a potential that is a quadrilateral with the potential to be a parallelogram. I want this to be a parallelogram. So what do I have to make true in order for this to be a parallelogram? So think about our 5 things. If I can show what, can I make this a parallelogram? So what can I show that would make this a parallelogram?
congruent sides.
Congruent sides. Is that what you were going to say, Tyler? Okay, if we can show that opposite sides are congruent, then we'll have a parallelogram. So we're going to find the x and the y that will make that happen. So I'm going to find the x that will make these 2 equal. I'm then going to find the y that will make these 2 equal.
It's x plus 2, not y plus 2.
I did put x plus 2.
I thought that was, like a mistake.
Ah, gotcha. So when we solve each of these, we get x is equal to 6, and then we plug 6 in over here, and we get that y is equal to 8. This means that if x is 6 and y is 8, we will have a parallelogram. Okay? So the only thing that's really different in how you do the front page and how you do these 4, 12 to 15, is just one of them you don't know it's a parallelogram. The other one, you're making it a parallelogram. How you do it is exactly the same. So you'll still set opposite sides equal. You'll still set opposite angles equal. You'll still set consecutive equal to 180, add them up and equal to 180, and diagonals will still bisect each other. Those four properties are still there. We just don't know for sure it's a parallelogram. We're showing it's a parallelogram. Okay? So, are there any questions